Hey guys, welcome to another video of this is based on computer architecture. So this one is based on fetch, decode, and execute. Now we'll be just looking at a single instruction. Let's just take, for example, we have this instruction which says load contents of location 4. This is a single instruction. So this fetch decode happens in the following way. So it happens between the CPU and the memory. Now this is our CPU, this is our memory. If you watched our previous what's this if you watch our previous video, you will be able to to understand this. Now we have our iteration, which is 0 2 4 6. Now this is where we have our first instruction, which is the load whatever contents of location 4. Now in our CPU we have what you call a control unit, and then we have what you call an allo. So this is a CU. Let me just use another color for this. We have an CU, we have an allo. Now inside this allo we have what you call an accumulator, right? So let me just I don't know if I should, yeah, let me just use white. Then we have an accumulator, and here you have what you call your program counter, and here you have what you call your current instruction register. Then on your side you have what you call the memory address register and also the data register. Right, now other than that, you're going to be having your buses. So this is your control bus, and then let me choose another different color, light one. And then you're going to have another bus which will be your address bus, and also you're going to be having your data bus, right? Now let's look at how this goes. Right now what happened is that the PC, it is the first step which has the iteration, right, which almost every time it starts at 0. Right now when it starts at 0, it takes that 0 and load it to the MAR. Right now, okay, let me just write this 0 on the side so that I want us to understand it in the following way. Let me just please be patient with me. Now let's write our 0 here, which is our location. Right now, here is what I want us to focus on. So let's say this is the 0 on the iteration. Now this 0, which is the location in the memory address, is then copied to the MAR. Now when it is copied to the MAR, what happens is that the control unit, what it does, it will send what is known as the read signal through the control bus. This is our control bus, this is our address bus, this is our data bus. Now the CU will send the read signal to the memory address. Now when it sends that, the next step that will happen, since we have enabled a read mode, it means that this location will be sent through address bus. Now when it is sent to look for this location 0 here, and then when it is found, it now takes this instruction here and then it takes it what? It takes it back through the data bus. And then when it is taken back to the CPU through the data bus, it is now copied here on the data register. Now after on the data register, since it's an instruction, it is then loaded to the what? To the current instruction register. Now we have fetched our instruction, right? Now after fetching our instruction, we have to what? We have to decode the instruction, right? Now, so this is the load part, right? Now this load part, when it is decoded, it tells the CPU what to do, right? In terms of binary, it means that since it says load the content of location 4, let me just take it again. It means that, oh, I'm sorry, let's take it again. It means that this instruction in the CIR, it will be taken to the data register, right? And then after the data register, it will be sent to the accumulator so that it can be what? It can be decoded. When it is decoded, it is found out that it has what is known as the location of what? The location of the next instruction. So since it says load the content of location 4, now it's time to execute. Since we have decoded the message, now the message is decoded in such a way that the alum knows that we have an instruction to go to location 4. Now that location 4, it is copied to MAR here, right? Since it is copied to the MAR, let's just take this one, let's delete, let's replace it with location 4. Let me do this. Okay, I think this will be very hard to do because they're not on a same place. Yeah, this is our. So the thing is that the alum, not the alum, so the accumulator, it decoded the message which says load what's in location 4, meaning that since we have location 4, which is an memory address, this memory address will be sent to the will be copied to the MAR. When it is copied to the MAR, you must understand that a read signal must be sent through control bus to the memory in order for us to read, right? After it is sent, after the read it is sent, now that location will be sent through the address bus to try and look in location 4. Now since now we are in what you call the location 4, what will happen next is that since it said load, it will take the contents in location 4. Now please understand this, it doesn't take the address, it takes the data. It doesn't take instruction but the data, right? Meaning that now we are taking sorry about that, we are taking what's inside memory number 4, which is the data. We are taking it back through the data bus, and then it is held in the data register. Then after data register, it is loaded to the accumulator. Now let me simply explain this again. Now let's have 4 different things so that we don't have to make mistake again, right? Now let me just have another location. This is a bit of confusing actually. Now this is memory 0, and then this is our instruction here, the load. Now let's take our load here, let's represent it with something actually. Let's represent our load in a different manner. Let's make it a bold red. Okay, let's write a load. Now we're going to start again afresh. I'm going to explain this step by step. Okay, the iteration starts at 0, as you know. That's the program count. Program counter starts at 0, and then it takes this 0, which represent the memory uh, 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 location of where the instruction or the first instruction which is supposed to be executed it is at. Now this location, it is copied to the MAR. In order for us to be able to read the memory, it means that control signals are sent through the control bus, right? After they are sent through the control bus, it means that this location which is copied to the MAR, it is sent down the address bus. Then it looks for this location that it has, which is 0. Now this location which is 0 here, it consists of an instruction which says load. Now this instruction, it is taken back through the data bus and is copied to the data register. Then after data register, it is taken to current instruction register. Now we have done with what? With fetching our instruction, right? Now for decoding this instruction load, it is copied to what? To the data register. Then it is copied to the accumulator so that it can be decoded. When it is decoded, remember our instruction, our instruction here says in full. This is just a short instruction. It is not a full instruction, it just says load. But the full instruction says load the content of location 4. We are loading content of locations 4, meaning that when this is decoded, we are finding a location 4, meaning that that location 4, which is this one, since this is what we found, it is then copied to the memory address register. Now since it is in the memory address register, now we want to take what is in memory address register 4, right? Your memory 4, right? It means that before we go through the address bus, the controls, the read signals are sent through the control bus, right? Therefore your location, it is then sent to the memory, and we arrive at 4, right? Now when we arrive at 4, let's just assume in location number 4 we have a data or a value 3. Now this data or value 3, it is taken to the CPU through the data bus, and it is now copied to the what? To the data register. After the data register, this 3 is then loaded to the accumulator. So basically we took the instruction of 0, which is I'm sorry about that, which is this. Okay, I will make mistakes. So what we did in simple terms, we took what is in location 0, which is here, which is the instruction. We took it to the CPU and decode it. After decoding it, we found it saying go to location 4 and take what's in location 4. Then since we have location 4, it is copied to what? To the MAR. and then send down the address bus. We go to location 4, we find the value 3, we take it down the data bus, copy it to the data register, and then copy it to the accumulator. That's how you loaded the contents of location 4. Thanks for watching this video. I hope you found it very helpful.